Hey, welcome back. This is 0965, and I'm checking to make sure my microphone is working. Hold on. Looks okay. Today we want to look at 6.5, where we introduce the kind of overall strategy for factoring. Okay, so I'll begin, and the book will also begin by giving you kind of a program to follow. And so by no means do we have this memorized, but if we were going to, for example, program a computer to do this for us, then we would probably use this as kind of a template for what we were going to do. But hopefully you can look at it and appreciate, well, yeah, this is kind of what I do in my brain, if not explicitly stated, then implicitly. Okay. So anyways, the strategy, the first thing that we always want to look for and we always want to do is to factor out any greatest common factors. So factor out any GCFs. Okay. Secondly, then, we're going to look at the number of terms and then factor based on the number of terms. Okay, so factor based on number of terms. Okay. So first, if we have two terms, we dealt with several versions of that, right? So there was the a squared plus b squared, which turned out to always be prime, so there wouldn't be any factoring there. Okay. There's the a squared minus b squared, which was the difference of squares, which we know we can always factor as a plus b times a minus b. And then there were the cubic types. So if we had a cubed plus b cubed, we use SOAP for the signs, so it's always going to be same sign, and then opposite, and then always positive. And then we'll have a b, and then a squared, ab, and then b squared. And then the other version, a cubed minus b cubed, would be a minus b, and then we would have opposite sign, and then always positive here. So then same terms, a squared and ab, and then b squared. Okay. And I just want to make sure I note what my video quiz is for today. So before I get too far into it, I always forget the video quiz. It's coming up. Okay, so I'll remind you when I get to it, but I'm just noting it down for my records which one it is. Okay, so let's keep on going with our program here. If you have three terms, we really only had two kind of quote-unquote special forms. It would be things like a squared plus 2ab plus b squared, and that would always factor in the a plus b times a plus b, or if you'd rather, a plus b squared. And then there was the other variation of that, a squared minus 2ab plus b squared, and that'll just be a minus b times a minus b. Other than that, we had our three basic forms based off the signs, and in those cases we would use trial and error. So I'm rather than writing all that out again, I'm just going to put trial and error. Okay. Okay. The other case would be four or more. So I maybe put that over here. Four or more terms. And in these cases, you would probably try to do grouping. Okay, so that was really, at this point, the only technique we have for dealing with these forms. Later on, we'll be able to do long division as well, but for now, it's all we can pretty much do is grouping. Okay. Okay. So once you kind of go through that rigmarole, you'll step back and take a look and see if you can continue factoring more. So can you factor anything else? And then finally, you should check by multiplying it all back out, at least in your head. I won't take off points on the test if you don't check, but you know, you want all the points you can get. You don't want to have to take this class again or something like that. So check. Okay, so check by multiplying out. And like I said, you could do this in your head. All right, let's just then, at this point, look at a whole bunch of examples from the book. So negative 7x squared plus 35x. Usually when you factor out and there's a leading term that's negative, you want to factor that negative out with the GCF. Okay. If I don't tell you whether or not, I mean, it's really up to you, but generally if that first term is negative, you want to factor the negative out with the GCF, okay? Okay, so I can factor out the negative, and then 7 divides both 7 and 35, and then x is common to x squared and x. So I'm factoring that out. The leftover parts inside, because I'm factoring out a negative, this will be a minus sign. And then I'll have 1x kind of left over, and then 5 times negative 7x will give me the 35x. Okay? And then, of course, redistribute, make sure it works. 7x squared plus 35x. Okay. Sometimes it helps to cover up what you're working on. Sorry. So it's like you already know the answer. So if you sort of cover up this part with your hand and then redo the distribution, negative 7x squared plus 35x, it prevents you from doing what they call in psychology self-fulfilling prophecy, right? Because you kind of know what the answer should be, and your brain will sort of try to make it that way, even if it's not right. Anyways, take a psychology class. You know? Anyways, 100x squared minus 81. This looks like a difference of squares, right? Because a, in this case, I believe will be 10x, and then b will be 9. So we should be able to go 10x plus 9, and then 10x minus 9. Let's see, 64x cubed minus 1. Okay, scanning it, there's no way to factor out a GCF. There's no GCF other than 1. There's a cube there, so this seems like it's a difference of cubes. So A, what times what is 64? Well, I believe that's 4, right? And then you also need an X. And then B, what times what is 1? Well, it's just 1. And so here we go. Set up our parentheses. Same sign, opposite, always positive. So it'll be 4x minus 1. And then we have a squared. So 4x squared is 16x squared. Make sure you square the 4 as well. And then a times b is just 4x. And then finally b squared is 1. I usually don't check these because it takes too long, but if you have time at the end of the test, just go back and check it real quick. Let's look at another one. Okay, so here I look at this and it has 4 terms, so I'm thinking grouping, right? So I'm going to group these two together, group these two together, and see what happens. So in the first two, there's a common factor of 7. And then the second two, there's a common factor of x. Then each of these terms, so this is one term, this is one term, each of those terms has a common factor of x plus y. So I can factor out the x plus y, put that in front, and then I'm left with the stuff in front here, right? So it would be 7 plus x. And that would be our final factorization. And then you could multiply it back out if you want. And check it real quick. 3x squared plus 2x minus 5. Okay, so there's no common factor here. This is a trinomial with leading coefficient not equal to 1. So it's usually a little bit more work. I can at least get the signs. It has to be plus and minus. And then this is going to have to be 5 and 1 or 1 and 5. And this will have to be 3x and x or x and 3x, right? And I can start going through these variations to see what works. So for the first one, the middle terms here would give me 5x, and the outer terms here would give me 3x. So if you subtract those two, you would definitely get 2x. So just got to make sure I get the signs correct, right? So if it's plus and then minus over here, I'll have 5x minus 3x, which will be 2x, which works. Okay, so it's going to be 3. I got lucky. X minus 1. Now I'm going to make sure, so 3x squared the first, minus the outer, plus the inner, and then the last one, and that works. 3x squared plus 2x minus 5. Okay, let's get another one. There's tons of examples. 4x cubed minus 100x. Okay, so you look at this and you may think, whoa, that's a cubic, right? Because you see that 3 as an exponent, but it's not true. There's a GCF there. Not just x, but 4x. So I'll be left with, on the inside, x squared minus 25. Okay. And then maybe you think you're done, right? But you have to kind of step back and you say, hey, wait a second. This thing right here is a difference of squares, so I can continue on. This would be 4x times x minus 5, x plus 5, x minus 5, if you wish. You could also write x minus 5, x plus 5, but that would be the final factorization. So don't stop before you're done, is the kind of the moral of that story. Okay. All right. Let's get 20. This example here. I got them numbered, but sometimes the numbers are the same as what's in the book. So again, this kind of, it doesn't look like a cubic here at first, but it does have a GCF. You can factor out a 7, right? So you have 7 times x to the 4th minus 1. Then this thing here can be factored as well. It's a difference of squares. It's just that the a value is x squared, and then the b value is 1. Because x squared, recall, x squared times x squared is what? Well, that's x to the 4th, right? Okay, so you could factor it, long story short. And let's see what we get. So I need an x squared here, and it'll be plus, minus, and then 1 here and 1 here. And you step back and think about it, I'm not done, right? This one here is a sum of squares, it's prime. But this one here, you could factor it. That is a difference of squares again. So you're not done. You have 7 times x squared plus 1 times, now I can factor this into x plus 1 times x minus 1. Okay. And then I'm done. So you want a complete factorization, not just partial. So on the test, I can give partial credit because I'm having you write out your test. So you would lose points, but you would get partial credit for this answer here, right? And I'd probably give you 1 point for this, and then 2 points for this, and then full credit for this. Okay. Let's look at another one. So x cubed plus 3x squared minus 25x minus 75. Okay, again, this is 4 terms, right? So it's probably grouping of some sort. I'm going to group these guys together and these guys together. On the first 2, I can factor out an x squared. So I'll be left with x plus 3. And the second 2, I can factor out negative 25. And you have to factor out the negative, because if not, then you're not going to have that common binomial of x plus 3. You'd have x plus 3, and the next one you have negative x minus 3. So you have to factor out the negative. I'll have then left over x plus 3, like I want. And then I could factor out binomial x plus 3. And then I'm left with x squared minus 25. Okay, it seems like you did a lot of work, right? And you're done, but no, you're not. This thing right here is a difference of squares. So you still need to carry on and complete the problem. X squared minus 25, I'll set up my parentheses, got to be plus minus xx. And then what squared is 25? Well, 5, right? So 5 times 5. let's look at, let's see, sure, let's look at this one. I'm looking through my notes. 5x cubed minus 20x squared plus 20x. So looking for a GCF, and that's where you always start. That's your first step for a GCF, and hopefully they just jump out at you after a while. You do enough of these, you're going to be like, oh, there it is. It'll be screaming at you, right? So each term is divisible by 5, and there's a common factor of x to each term. Okay, so let's see what we got left over. X squared minus 4x plus 4. Okay. You're not done, right? Because you can factor this thing right here. So let's see, 5x times, and set up my parentheses. I got minus x, and it's like 4 and 1 or 2 and 2, right? And this is going to be 2 and 2. Okay. You can leave your answer in that form, but you can also rewrite it as 5x times x minus 2 squared. Okay, so that's a compact version, if you wish. But either answer would be fine. I would give you full credit for this or this. Okay, let's carry on. The next problem is the video quiz question. Video quiz, video quiz, video quiz, video quiz. Okay, 48a to the 4th minus 3a squared equals. Okay, so just, again, we have to factor this thing. I can factor out a 3. I can also pull out an a squared. Okay, so 48 divided by 3, I believe, is 16, and then there's 2 factors of a left, and then minus 1. Are you done? No, of course not. You could still factor that. That's the difference of squares. Okay, so I'd have 3a squared times, I'm going to start my parentheses. So this will, what times what is 16a squared? Well, 4a times 4a. This has to be plus minus. What times what is 1? 1. Okay, and then that would be it. Okay, it's just a couple more, and then we'll go into my math lab and see if they have anything terribly difficult. Okay, so we want some multivariable type questions before we dive in there. Xy minus 5x plus 2y minus 10. 4 terms, so you're thinking probably grouping. Okay. The first 2 terms I could factor out an x. I'll be left with y minus 5. And the second 2 terms I could factor out a 2. Again, you get a y minus 5. So there's that common factor of y minus 5. Okay. So you'll factor that out, and you're left with x plus 2. And that would be your factorization. One last one, one hard one, and then we'll carry on line. 24a to the 4th b, so that's my letter b, plus 60 a cubed b squared plus 150 a squared b cubed. Okay, so the greatest common factor, what's the biggest number that divides into each one of those? Okay, so the biggest number that divides all 3 of them, I'm thinking probably like 6. You may have to play around with your calculator a little bit. Okay. I believe it's 6, and then the highest number of a's common to all of them, say squared. The highest number of b's, just 1 b apparently. Okay, 24 divided by 6 is 4, and then we have 2 a's left over, plus 60 divided by 6 is 10. So maybe I could have factored out another 2, I don't know, we'll find out. And then we have an a, and then another b, and then finally plus 6 into 150, 2, 12, 35, 25. Yeah, so 6 would be the greatest common factor amongst the constant terms. Then we have just 1b left over. Okay. We're not done. We still have to factor this material. So we have 6a squared b And then let me get my parentheses ready. This looks like one of our common forms, right? Our identifiable forms, probably 2a and 5. 2a and 5b. And this time I am going to sort of check it, at least check this part of it. So first is 4a squared. Yeah, so that's not going to work because it's 10 and 10. So I think I copied the problem down wrong or something. Yeah, I must have copied it down wrong. I apologize. Here, let me cheat a little bit. I'm sorry. I don't like doing this usually, but and then let's make this 120, or what is 6 times, yeah, 120. Just don't make this 120. Sorry about that. Just then it works, right? So 6 times 20 is 120. And a cubed. Do not do that on test. I can do this because I'm the one that's making up the problems. Okay, so the first would be 4a squared, and then the outer plus 10ab, the inner plus 10ab, then the last 25b squared. So I lost a squared on that guy. Okay. It's always a good idea to check your work there. Okay, let's dive into my math lab and see what kind of craziness they have set up for us. I'm just kind of looking at the last couple problems, which I assume will be harder. If there anything is really troubling you, you can always send me an email, ask your instructor. Let's take a look. 3x to the 4th plus 14x squared minus 5. Okay. So it looks like it's got to be plus minus. You're probably going to have a 3x squared and then x squared and then something like 5 and 1 or 1 and 5. Okay. Okay, so it'd be 3 and then plus 5 is not going to work, right? Because you're going to end up with the outer term being negative 3x squared, the inner term plus 5x squared. So you get 2x squared, which is not 14. You're looking for 14x squared. Okay, so try again. X squared. So it has to be 1 and 5. And just maybe the signs are off, but we can worry about that here. So the outer is negative 15x squared. The inner will be plus 1x squared. That'll give you negative 14x squared, but we want positive, so all you have to do is change the signs. So this would be minus, and then we'll make this one plus, and that should work. Right? So the outers would be positive 15x squared. The inners minus x squared. And then you get positive 14x squared. So it's going to be 3x squared minus 1, and then x squared plus 5. Sure, x caret squared plus 5 parentheses 3x caret squared minus 1 and parentheses. And check. Oh, what's next? This guy looks kind of funny. This is really a weird one. Sometimes you really have to get creative, and a lot of math seems very, very kind of like you could teach a computer how to do it. Some of it, though, you really need a human to think outside the box creatively. Some people argue that you can get a computer to think creatively. I think that's true to a certain extent, but they have their own kind of creativity. A computer's creativity is different than our creativity. Anyways, let's take a look at this guy, right? The trick will be to kind of seeing this part as something special. So what is that part as something special? It's x plus 9 times x plus 9. That's 4a squared. And then you could rewrite that as x plus 9 squared minus 4a squared. So what's happening here is you have a difference of squares. There's the first one, there's the second one. So a is x plus 9 and b is 2a. Right? So you'd have x plus 9 plus 2a times x plus 9 minus 2a. Or if you would rather, you could drop these parentheses in here. That's the associative law. You don't need them. Plus 2a and x plus 9. I don't think the associative law says you could drop the parentheses, but the associative law is about parentheses. Okay, so let me type that in. X plus 9 plus 2a. And x plus 9 minus 2a. I hope that's it. Okay. Application, more physics type stuff. You have a 1,936 foot cliff. Some idiot is dropping a rock from the cliff. The height of the rock is modeled by this, I'll call it h of t, 1936 minus 16t squared. And so what do we want to do? We want to first factor the thing. Okay, so let me just, get your calculator, calc, and divide 1936 by 16. Which is 121. And then note that this factor here is a difference of squares, so you could rewrite that as 16 times, and 11 squared is 121. It's t minus t, and then we should be good to type that in. Nothing else to do with the problem, apparently. This t and 11 minus t. What's next? Express the area of the shaded ring. So this is like a donut problem. You take the area of the big guy and then subtract away the area of the donut hole, and you should be good. So the radius of the big guy is b, as in banana, and then the radius of the little guy is apparently 6. It's unfortunate my 6's and b's look very similar. But anyways, express the area of the ring in terms of pi. As recall, the area of a circle is pi r squared. So the bigger portion will be pi times b squared, and then minus pi times 6 squared. Right? And then the area of the shaded ring can be expressed as do not factor. Okay, well, let's just write pi b squared minus 36 pi. Okay, pi b squared minus 36 pi's. Then the area of the shaded ring factored completely, so we can factor out a pi. So this will become pi, and then we'll be off to b squared minus 36, which is the difference of squares. So I could write that as b plus 6 and then b minus 6. Again, sadly, my b's and 6's look exactly the same. Pi, I am aware of the issue, plus 6, and then b minus 6 in parentheses. Check answer. Yay! Oh, more headaches, right? Factor completely 5x squared minus 35x cubed minus 90x. Well, it looks like I can pull out a 5 and an x. Okay. So at least we have that much. X minus 7x squared minus divided by 5, 1, 5, 4, 18. That's 18. 2 and 9 will probably flip the bill there. So it's a x plus x minus scenario. 2 and 9 with the bigger number negative. Should be like that. Now let's just throw it in the machine. I get several chances. I'm getting lazy. 2 and then x minus 9. Oh no. Sadly I am incorrect. heck did I do? Oh, they tricked me. Or no, I tricked myself. It's 5x to the 5th. 5x to the 5th. Sorry, folks. 5x to the 5th. That means I want to pull out. Well, if I pull out a factor, so it'd be x to the 4th. This would have to be 2 and 2, and then you can continue on with this one. It's supposed to be 5x. Sorry, folks. Square root plus 2. I had not rehearsed this ahead of time. In my defense. It's minus 3. So some of it is kind of right. Squared. And then this will be x minus 3 times x plus 3. So make sure you always want to make sure you copy the problem down correctly. Maybe it was the moral of that story. Let's take a look at this character. 4x to the 4th, getting close to the end. 41x squared plus 45. Well, I can't pull out a 4. I can't pull out a 2. These guys are odd. I can't really pull out an x, so I'm kind of stuck everywhere I turn. Let's see if we can factor it like this. So maybe, and then I don't even know really the factorization. About all I could say is the signs have to be minus, minus. And then we're thinking something like 9 and 5, some variation of that. And I'm thinking 4 here to give you a 36, and then a 1 here would give you 5. And then when you add 36 and 5, you get 41, right? Just have to put it all in here. So we got an x squared minus 9, and then a 4x squared minus 5. So again, I want to make sure that worked. So I get 4x to the 4th outer minus 5x squared inner minus 36x squared last plus 45. And that's 41, so it looks good. Not done, right? This is a perfect square, difference of squares. So this would be x minus 3 times x plus 3, or if you'd rather, x plus 3, x minus 3, and then times 4x squared minus 5. Let's see what the computer says about all that. X minus 3 times x plus 3 times 4x squared minus 5 and parentheses enter. Yay! One more. Ugh, one of these. Okay. So we have 5x to the 2n minus 180y to the 2n. I can pull out a 5. 3, 15, 6. So 5 times x to the 2n minus 36y to the 2n. So that's a difference of squares. It's just going to give me 5x to the n and x to the n. Because when you multiply x to the n times x to the n, you add the exponents for the like base. Right? And you end up with x to the 2n plus minus simple 6y to the n, 6y to the n. Okay. And that should do us. Don't forget the GCF is sitting in front. And this 6y to the n times the same thing, sort of x to the n, whoops, minus 6y to the n. The exponent. Let's see what it says. Yay. Okay, so hopefully I'll get you through it. Thank you for watching, and we will see you next time.